Software engineering, a journey from past to future. Introduction. Software engineering, at its core, is the systematic design, development, and maintenance of software applications. It encompasses a broad range of activities, from requirements gathering and system design to coding, testing, and maintenance. Over the years, software engineering has evolved significantly, adapting to the changing technological landscape and the increasing complexity of software systems. History and development. Early beginnings, 1950s to 1960s. The term software engineering was coined in the late 1960s, but the discipline's roots trace back to the 1950s. During this era, software was often bundled with hardware, and there was little distinction between the two. Programming was more of an art than a science, with individual programmers devising their own methods. Structured programming, 1970s. As software systems grew in complexity, the need for a more systematic approach became evident. This decade saw the rise of structured programming, which emphasized logical structure and clarity. Techniques like top-down design and modular programming became popular. Object-oriented paradigm, 1980s. The 1980s introduced object-oriented programming, OOP, which focused on encapsulating data and functions into objects. This paradigm shift led to languages like C++ and Java, which are still widely used today. Agile and iterative development, 1990s to 2000s. Traditional waterfall development models, which were linear and sequential, began to be challenged by more flexible, iterative approaches. The Agile Manifesto, published in 2001, advocated for adaptive planning, evolutionary development, and early delivery. DevOps and continuous integration, 2010s. The integration of development and operations, DevOps, emphasized the need for continuous integration and delivery. Tools like Jenkins, Docker, and Kubernetes emerged, facilitating more efficient development, testing, and deployment cycles. Current practices and instruments. Microservices architecture. Modern software systems often adopt a microservices architecture, where each component or service runs independently. This modular approach enhances scalability and maintainability. Cloud computing. Platforms like AWS, Azure, and Google Cloud have revolutionized how software is deployed and scaled, offering a range of services from computing power to database storage. Automated testing. Automation in testing ensures that software products are robust and reliable. Tools like Selenium and JUnit facilitate this automation, ensuring consistent quality. Version control. Tools like Git and platforms like GitHub and Bitbucket have become essential for collaborative development, allowing teams to track changes and manage codebases efficiently. Vision of the future. Artificial intelligence in development, AI and machine learning will play a pivotal role in automating mundane coding tasks, bug fixing, and even software design. Quantum computing. As quantum computers become more accessible, software engineering will need to adapt to harness their unparalleled computational power. Virtual and augmented reality. The rise of VR and AR will necessitate new software engineering techniques and tools tailored to these immersive environments. Ethical and responsible development. With increasing concerns about privacy and security, future software engineers will need to prioritize ethical considerations in their work. Conclusion. Software engineering has come a long way from its early days of ad hoc coding practices. As technology continues to evolve, so will the methodologies, tools, and practices of software engineering. The future promises exciting innovations, and software engineers will be at the forefront, shaping the digital landscape of tomorrow.